In Lesson 7 of Unit 5, we will now be adding fractions with unlike denominators symbolically. So we have reached the stage where we can complete an addition calculation for fractions with unlike denominators using only numbers, symbols to complete this calculation. So when adding fractions with unlike denominators, here's our little recipe. You will find the least common denominator for all fractions involved. We will then write equivalent fractions where necessary so that all fractions have a common denominator. We will then keep the same denominator in our answer. We will add our numerators, and then, of course, simplify if necessary. So let's have a look at a few examples. Add the following. And as we proceed through these examples, we'll use our recipe or the fancy word algorithm to help us figure out the answers to these addition calculations. So in A, we have a quarter plus 3/8. We notice that our denominators are indeed different. So our first step is to figure out what our LCD is. If I look at my multiples of 4, 4, 8, 12, and I don't need to go very far here because I realize right away that my common denominator will be 8. So I go back to my calculation and I need to write an equivalent fraction for 1/4 with a denominator of 8. Well, 4 times what gives me 8? That would be a 2. So I multiply my numerator by 2, and 1 times 2 is 2. So 1/4 is equivalent to 2/8. My second fraction here, I don't need to do anything with it because it already has a denominator of 8. So now we have a common denominator. Let's add away. So the next step in the algorithm is to put down the 8, and we add our 2 and 3, giving us 5. We check for simplest form, and we are good. 5/8 is lowest terms. In B, 3/11 plus 2/5. Denominators again, different. So let's see. 11 and a 5. Let's start listing some multiples of 11. 11, 22, 33, 44, 55, 66, and I'm going to stop there. For my multiples of 5, 5, 10, 15, 20, nope, nothing in common yet. 25, 30, 35, 40, nope, nothing in common yet. 45, 50, 55, there we go. So our LCD is 55. So yeah, we had to list off a few multiples that time before we found a common one. But that's okay. This time, I need to write 2 equivalent fractions that have a denominator of 55. So I need to figure out 11 times what gives me 55. Well, you may not just know right away that it's 11 times 5, and that's great. And then 3 times 5 is 15. I could have also looked at where I listed my multiples. And I got 1, 2, 3, 4. So the fifth multiple gives me 55. So that tells me I'm multiplying 11 by 5 to get 55. 5 times what gives me 55? Well, if 11 times 5 is 55, then 5 times 11 got to be 55. And 2 times 11, 22. 2 equivalent fractions, common denominator. Write down that common denominator, and let's add our numerators. 15 plus a 22 will give us 37. And believe it or not, that is simplest form. In C, 1/7 plus 1/3. Common denominator this time. Well, if I list out multiples, 7, 14, 21, 28, And I could keep going. 3, 3, 6, 9, 12, 15, 18. Ah, there it is. 21. So I rewrite both given fractions with a denominator of 21. 7 times 3 is 21. Multiply the numerator by 3, I get 3. 3 times 7 is 21. Multiply the numerator by 7, I get 7. So I have 3 over 21 plus 7 over 21. Common denominator is 21. Add the numerators, and I get 10. And that, too, is simplest form. In our fourth example, we actually have 3 fractions being added together, but that's fine. We approach it the same way. So if we look at all 3 denominators, all 3 are different. So we need the LCD for 2, 9, and 18. And if you wanted to list out your multiples again, as we've been doing, you can. You will discover that the LCD for these 3 fractions is actually 18. So for the half, I'll need to write an equivalent fraction. For the 2/9, I'll need to write an equivalent fraction. For the 5 over 18, I just leave as is. Denominator is already 18. So, okay, let's go back to the half. 2 times what gives me 18? That would be a 9. And 1 times 9 is a 9. So a half and 9 over 18 are equivalent. 9 times 2 gives me 18. 2 times 2 is 4. So 2/9 is equivalent to 4/18. We have a common denominator now of 18 all the way through. Copy it down. And then I add them up. 9 plus 4 plus 5. Ooh, that's pretty cool. That actually equals 18. So we have an answer of 18 over 18. Well, if you have 18 parts of a whole out of 18, then that means you have 1 whole. And never ever forget the idea of any number divided by itself is 1. So our final answer here, simplified, 1. And I'd now like you to proceed to the next video in this lesson.